Hello, we are live. It is me, Jenna Bryant, Jess Frazelle, Jordan Noone. We're back building our 8-bit computer from scratch on breadboards. For those of you who tuned in last week, we are debugging and troubleshooting an issue that we came upon, or that we stumbled upon. Jess, Jordan, why don't y'all give a summary of what happened last week and the week before and what we're going to work on today?
Yeah, so we've been building out our 8-bit registers. We're going to have 3 of them, but we really need to get the first one working first. So this is comprised of 2 4-bit register chips. And basically we went to go test this by lighting up some LEDs, like saving some data, and then like trying to offload the data onto our bus, which we will have a larger bus when we have 3 of them. And it's not working correctly. And so we've been debugging it, trying to see how power moves throughout the board. We've learned a lot about various things along the way, but we're still kind of in the debugging phases, and we're just gonna kind of trace the power throughout the board probably today.
Ooh, and guess what? Jordan got me a surprise.
I did?
Look. So,
oh, is it a LED magnifying glass?
I've always wanted one of these. And I've said, ooh, I want to be able to be like, ooh, let me look in my, oh, hey, let's look in the magnifying glass. Inspector Jenna, right? How cool is that?
That's dope.
That is dope.
So, while y'all are, actually, I don't have my instructions pulled up. So, actually, perfect. Oh, there are the instructions in the chat. Britt, thanks for posting that. And hey, Hannah. Luigi! What's happening? It's me, Mario. It's me, Mario.
So do we have the multimeter over there still?
We sure do.
Sweet. So actually, let's like try to show them and reproduce like the weird things that we were seeing, like where if you kind of like finagle some different parts of the board, the clock lights up.
All right.
So power everything on.
Okay.
Yeah, make sure the grasshopper there is plugged in.
Okay. Oh, y'all. New nails, who this? Luigi! What's happening? Okay. Is this, the multimeter is not turned on.
Oh, you'll want to rotate the knob on it to, is that a great question?
Is it
it may help
HDTV?
That is a good question. Do you mind showing it on the screen?
I believe this is right.
No, you'll want to keep going a little bit. Or is that right? I'm going to sound really silly, Jess. I swear I know how to do this too, but if you don't mind confirming it's on the right setting.
I think so. Let me see.
Here are all the options.
I think that's right.
Yeah, that should be fine. I mean, we can test it. Like, why don't we just try it by powering on the board and like just seeing that the board has 5 volts?
Okay. And hang tight. I should make sure I have Discord pulled up. Ooh, Britt, can you pop our Discord info for the Jenna Learns Twitch stream? Y'all can join our Discord channel and ask questions as we go along. Let's see. Let's see. Here we go.
Can we zoom out a little bit? Sorry.
Yeah.
It's hard to see the whole thing, and we kind of need the whole thing.
Oh man, this camera's photobombing. I'm gonna go like this. How's that?
Okay, that's dope. Yeah, because we're gonna like just kind of try tweaking some stuff, and so yeah, this will be a good view.
Okay.
Sweet.
Okay, here we go. Boom.
Cool. Is it powered on?
Oh, the
This
board
board's
is on.
looking really good.
The board's on? Okay, so then if we do power to power, ground to ground of the multimeter, I just want to make sure it shows 5. Is this a new multimeter?
This is the same one as
Same one.
the other day.
I don't know why I was like picturing something different.
Power to power anywhere?
On the actual board itself, since we know that should be getting power, I just want to make sure that the multimeter says 5 volts so that we can
Like here?
Yeah.
The multimeter doesn't say anything.
I think it has to be turned on.
Oh, is it not?
Oh, perhaps change it back to off and then back to the spot that it's at now.
Yeah.
It turns off to save the battery.
And then ground to ground. Yeah, this is
All on the same one?
And it's plugged in, right? The board. Oh, there we go. Okay. There's a delay.
And they're all on the same one. See?
Yeah, nice. That's good. Oh, wait.
Oh, let me push harder. There we go.
Okay, there we go. Whew. Okay, so that's good. Now we know that this setting works, and you can unstuff the part. So basically, like what we were seeing is that if you like just kind of tapped some of the like cables and stuff, right? Like on the clock board, like that clock LED, like kind of goes off and on. Yeah, just like actually, we might have to trigger the.
Do we?
How are we doing this? I can't remember.
Were y'all flipping the switch or no?
Well, try manually cycling the clock just to make sure the clock's behaving. Like push the button.
Yeah.
Okay.
It's lighting up?
Yeah. Can you see it?
Yeah.
Yeah.
So do you want me to leave it on?
Turn it to manual mode.
Yeah. There we go.
Yeah. Okay, so that one works. Okay, so then basically, like if you move around some of the wires that look like less plugged in, it was like lighting up the clock. I don't know. I just kind of want to show people our weird thing that we could do.
On here? Just like wiggling them around?
Yeah, be gentle, but some of the like the white cables that are coming up, like the big ones, and then the blue and yellow.
Up here, these.
Yeah, just kind of start playing with things. Do any of them cause the LED to kind of light up very, very faintly?
No.
But are you seeing any kind of ghost currents
I'm
going
not seeing
through?
any ghost currents. No. Are y'all sure? Are y'all just trying to
No,
make me look like a ding dong?
It was trippy.
You're like, ooh, this will be funny. Let's have Jenna just like
No.
tapping the wires.
This is why we were going nuts, is because like we basically saw these like ghost currents going through. So then we were like, maybe we should trace the whole thing.
Are y'all okay? Are y'all feeling okay?
I mean, we might have been. I don't know why it's not doing it. Okay,
No, that's
well,
weird. Yeah, ghost currents. Okay. I'm just kidding. That's funny though. Huh. I can hear, okay, so Jordan, when he writes in the chat, just so y'all know what it sounds like, because he won't do it on command, it goes, He does it all day.
Okay, well, like regardless, when we turned on the board, so actually, I mean, let's check out where load and enable are, which of course now I always forget, but I wrote it down. So
Okay, it's 9, pin 9, and pin 7, or no, pin 9 and pin.
Where did that go?
I think it's pin 9 and pin 7 or something like that.
The load, I believe, is the one on the left, and the enable is the one on the right.
Wait.
Of those, the big cables coming up that we have been like toggling.
These.
So, yeah.
So that's this one's pin
and then
9.
there's so that's load.
Yep. And then this one is pin 15.
That's
19.
clear.
Or sorry,
19.
19. Sorry, 19.
Yeah, that's clear. And then the one on the far right,
Oh, wait,
so
hold
coming
on.
out of the 8-bit register.
Wait, hold on. Wait, 1, 2, 3. Wait, no, that's not 19. That's 15. Here, so this would be 19 up here.
Yeah.
Yeah.
So what are those plugged into?
So this one is 9 to this is positive. And then over here we have 19 both to positive.
Okay. So yeah, we want to bring load from high to low. So that would be the pin 9 to ground.
Okay. How's that?
Okay, so like those LEDs should have lit. Like this is why we know it's broken. But if we power cycle on the board now, what we were seeing before was that like the LEDs light if it starts in that mode.
If we power cycle.
So unplug the little grasshopper thing and plug it back in.
The grasshopper thing. It does look like a grasshopper. I'm glad that that's catching on. It does look like a grasshopper.
Yeah.
Good.
Yeah. Okay. So this isn't like. I mean, it's interesting that it does this. Like, a lot has to do with the defaults on the chip. The defaults on the chip are set to high, and so the bits like actually go to high. But like, it should also be doing it on the clock tick. But there's something trippy in the sequencing. So now what should happen is if we bring load, which is pin 9 back to high, nothing like the thing should stay lit.
Yep.
Okay, cool. So that's working as we want. And then if we bring enable from high to low, so pin 19 to ground.
Okay.
This should load the data onto our bus, but like we weren't seeing that happen, and it's not happening. And so, yeah, we now we were measuring the power around the 8-bit bus, which is the larger of the two chips, mostly to see like basically in the data sheet for that 8-bit bus chip, the behavior isn't like what we want. So if we put the multimeter, let me bring up the data sheet again. Sorry. Of course, all my like debugging tabs are gone from last week.
By the way, y'all, so we finished the stream last week, obviously in a distressed way, going, oh, what's happening? So I go and had like a few calls, and I come back, and Jordan and Jess are still here, just brainstorming and talking through this, and I was like, y'all.
But Jess spent like 2 hours on it.
Yeah, Jess did say she was going to be thinking about it the rest of the day, and G-Day too. It was so funny.
Yeah, so like our 8-bit bus, like it has 2 settings, and this is like either the data can go from like bus A to bus B, which is like the left-hand side of that chip, well, I guess the top in this view, to the bottom, which is what we want. We want it to go from the top of the chip to the bottom of the chip so that it lights the other LEDs. So like that's the mode that we have it set in. So that requires enable to be low, which is what we just put enable to low. And then the direction, which is pin 1 to be high. So just ensure that pin 1 is plugged into power.
Pin 1 on which one?
On the larger of the chips. Yeah.
Yes, it is.
Yeah. So if we put the multimeter on that, can we just ensure it's also 5?
Yeah. And so we'll put that in 1.
1 in that like row, and then 1 in ground.
Okay.
It can be any ground. Yeah.
Yeah.
So, okay, so this is like, we have it set up correctly. So like we're telling basically the chip, like put the data from the top to the bottom.
Yeah.
So this is what sucks. And then we were measuring the current of the actual data flowing. So what's the current on like kind of the top side of the chip? If you choose like any one of those other than the last one or the first one and put the multimeter in one of those rows, and then in ground, what do we get?
Wait, let y'all look. How cool is that?
That's dope.
Oh, by the way, I still have the tag, so don't judge. Whoa. Okay. Where do you need me to put it? But how neat is this?
Don't show them the price tag. Don't show them the
I
price
won't.
tag.
But it does say caution, radiation. Do not stare. Mike, wait, what? Oh, LED radiation.
I believe it's more don't stare into the light.
I'm like,
Not that it's
I'm
like radioactive.
I know. I'm like, what? That's a little dramatic. And didn't I tell you on the last stream that I looked right into the solar eclipse? I was like,
We need to get you some glasses.
I looked right at it and nothing happened. Meanwhile, I'm always talking about how I can't see anything. Oh, bless. Okay. So sorry, Jess. Where am I going?
Oh, so we're gonna go from basically like any of those like columns on the top side of the chip, like other than the first one and the last one, and also ground with the multimeter. So, because all of those are the ones where data flows through.
Okay. So any of these chips? Wait. Sorry. One more time. I was reading the chat and laughing.
So, the top of the larger chip, we want like pin 5 or
Okay.
any of them, like from
anywhere.
2 to 7, I think, or
Like
2
here?
to 9.
Like here?
Yeah, and then ground.
Oh gosh, my lights just turned off.
Oh, that's fine. Oh, something must have gotten disconnected actually. So we don't want to measure that until we get the lights back on again.
Is it just
So if we're gonna need to set enable back to high. So that's pin 19.
Did you see what happened to cause them to stop?
No, I just put the board back down. It was like this, and I went.
Is it
That's
still powered
interesting.
on? Like maybe try the clock.
You try manually
Yeah,
clicking the
that's on.
clock. Interesting, because when Jess and I were playing with this last week, we occasionally would get those lights to turn off, and we never really could determine what caused it to happen.
Yeah, that
but
was
they
weird.
did. It got like a ghost. How we were talking about ghosts. It got like a ghost command again.
Let's see. It was something
I
I went. It was when I went like this. What if it's like? Oh, I don't know. Something's wiggling, I think. Okay. Let me should I unplug and replug?
Yeah, but first we need to set enable back to high.
Oh, okay.
So pin 19.
Okay. Okay. Let's see. Oh no, my grasshopper came out.
Yeah.
Okay. Where was this again? Oh gosh, just anywhere over here. Okay, positive. And negative. There we go. Yeah, rats. Yeah, Britt, it was on, that's the exact one. It was July 2nd, 2019? When there was that solar eclipse and everyone was like getting the glasses that you get when you go to a 3D movie. Not really though.
I think they're different glasses than that.
I know, but they looked the same. They weren't this. They of course weren't 3D glasses, but you could buy the same, those paper ones.
Yeah, those were cool.
And I was like, I got this. I'm gonna look right into the light. Okay. Yes, they did look just like the 3D glasses from movies. Any ideas? Jordan. Okay, anyone?
So did we set enable back to high?
Yes.
Okay, and then did we plug it in?
Yep.
And it's not lighting up.
Yeah.
Okay, that's not good.
So just so y'all know, anyone joining, we are building a 8-bit computer from scratch on breadboards, and we are debugging at the moment. Something's going on. We got to get to the bottom of this.
Does it do anything if you cycle the clock? Is the clock lighting? Oh, okay.
Yeah.
I was like,
Ooh.
wait, there's something really wrong. Okay. Well, like our clock works really well, so
Our
there's
clock
that.
is
but,
on. Yeah. Our clock comes through. Now Jess is doing it.
I know we're like really running out of options here. And wait, what is a load set to right now? That's pin 9.
Oh, that is set to, that's high.
Oh, okay. So move that back to low.
Okay.
And then cycle the power. We can never get them to light, honestly, when it's like this.
Oh, it like flickered.
Okay.
Hold on. Do you see that?
Yeah.
It's like
it was doing this with us too. It's not good. It's like really
What
weird.
is happening?
I'm sus of the 8-bit register.
Should we replace it? Do we have another one?
We do have another one, but I'm a little confused on. Well, I don't. If we manage to like damage it, I don't want to damage a second one. So it may be worth kind of poking around a little bit more first. Make sure everything's nice and clean.
I'm just like pushing everything back in, making sure nothing's loose.
Also, I did want to say that we have a very special guest in the audience. I don't think he's spoke up in chat yet, but Dr. SC STEM is watching.
Oh, yay! He is a pro on Twitch. He had his first stream last week, and we were watching, and I was like, oh man, we need to learn from him. So Britt, make sure to put his Twitch stream in chat. He'll be streaming again on Friday at 1:30, I believe. And Barney Tet, Jess Fraz here. Jess is here. She is on audio. I think we need Jess. I think we need y'all in video though. Rotscale, hello. July 2nd is the next stream for Darren. Awesome. We'll be watching. Yeah, Jess, we need you. Barney Ted says, Jess, we need you.
Yeah, so I guess like we need the LEDs to light again to show people like why we're suspicious of the 8-bit register, because like then we can show that like the voltages on the two sides of the register are just totally not what they should be.
Okay, let's see.
So do we have, yeah, we have load is low and enable is high, right?
Here, let me show y'all. Let me get out my handy dandy. Maybe if I pick it up again, because that's what I did before.
Yeah, I mean, there's definitely like something off if like picking up the board and putting it back down is making like weird behavior happen, And this is like the same thing that we were seeing with like touching the random wires was causing the clock LED to light, which like is super weird.
Yeah. So Ratscale says, what exactly is an 8-bit computer? What's the use for it? I know nothing about hardware. Jess, Jordan, y'all are uniquely qualified to answer that question. There's
not much of like a real use case for it other than like, some simple math maybe, and slow math. But it's definitely not as I mean, it's a really good learning experience because then you learn about all the internals of computers.
Yeah. Could you build like on top of it? Something more robust or no? So, yeah, if we tried disconnecting and reconnecting the power again, I just we need the LEDs to light again and the fact that nothing is reproducible, even if we find a behavior is it's just super bad. There's I feel like there's more wrong than just the chip. Okay, there we go. There we go. Yeah, Darren says there used to be some really cool 8-bit computer games. That's what I thought. Yeah, I was asking Jordan yesterday if we could do an arcade game.
There's some basic stuff we can build on top of it, because you definitely can kind of programize that math into more complex things.
And yes, Barney Ted, you can make a clock with it. We have a clock that works. But look, Jess. Rotscale says,
okay,
I know. Jess Jordan, Rotscale says, does the 8-bit refer to having registers that are 1 byte each?
Yeah, I mean, that's what we're building right now is our register. So we have those 2 4-bit ones that add up to our 8. And we're going to have 3 of these. So, yeah. So we're in the state that we were in before, which is good. basically, like, we want to watch what's going to happen when we move enable to low. We want to watch the data flow through our 8-bit bus, basically.
What's
and so
supposed to
if we
happen?
put the multimeter on like the top of the, well, I mean, we can wait
What's
until we
that
do
up
the
here?
thing. So I guess, like, if you move, because you're not going to have enough hands. If you move enable, which is pin
19?
to low.
Hey, Jeff, I have a theory.
Yeah.
I think we should add those resistors to the outputs, the yellow LED outputs, at a 220 on each. I think we may be kind of like brown outing the 8-bit chip, just why it's acting so weird.
Oh, maybe.
We're like, without the resistors on the yellow LEDs, I think they're just drawing current, not enough to light them up, but enough that we're drawing so much current from it, it's behaving odd. So I think those resistors may help a lot.
Oh, nice. Should we
So-
try that, or like just show the voltage first so that people get it?
Yeah, Jenna, can you check the voltage over one of the yellow LEDs? So we're going to put the positive next to one leg of the yellow LED and then the ground of the multimeter on the other one. You may have to turn the multimeter on and off again, or off and then on.
Oh, you're right. So can I go just in like here? Anywhere?
Yeah, so it needs to
Back
be
on
Does it
now.
have to be
like inside the board, like
but I can't go on
the red one.
Yeah, put
So
one on
one on what?
put one on ground,
Okay.
and then the other one on like next to the input to the LED. Yeah.
Oh,
That's
there.
looking-
Except the far one. Hold on.
So you are getting a voltage there.
But that
That's
one,
fairly-
these,
Yeah,
these
did
on
they
the
all
end.
just light up?
Yeah, and they're still lit up.
Oh,
What just happened?
fascinating.
But the far end ones are not. Oh my god, I can hear myself. There's no-
Wait, when you put the multimeter in, they lit?
Y'all, what the heck? Yes. Let me try this one.
Jess, that's why I'm thinking something like they're current limited and like that just even the multimeter changed the flow through that leg because they had a voltage.
Yeah, but like they shouldn't have a
before.
voltage right now until we put enable to low.
Well, science, something's going on. I don't know.
Darren, do you
At
know
least
what's
like they're
happening?
lighting. They weren't even doing that before, but like that's trippy.
That's trippy. Let's add the resistors in.
Maybe it's because we're in the upside down.
Jess, how about we add the resistors? But yeah, I think
Yeah,
there's
let's do
some
that.
upside down work on.
Jordan doesn't know what we're
So,
talking about because
J-
he's never seen Stranger Things.
What?
Yes.
No, I saw Pirates of the Caribbean.
No.
They had some upside down.
Jordan's the worst nerd ever. You've never seen Stranger Things.
Yeah,
Never.
Stranger Things is really good.
It's the best. Hey,
Um,
and Stranger Things made D&D make a comeback, but I was playing D&D before it made the comeback. Still want to launch a new D&D
Chat
campaign.
has my back, Jenna. I think chat has
What?
my back.
Hannah. And stop.
Everyone's piling in here to say they haven't
Wait,
seen it.
hold on. I gotta switch view right now, and I have to talk to y'all. Okay, Darren, you have not seen Stranger Things? Oh my goodness, Luigi, have you not seen Stranger Things? Britt hasn't. I'm sorry. Okay, we're planning a movie night. Y'all, oh, Luigi has. Darren, Britt, Jordan, we're having a movie night. We're gonna stream Stranger Things every season. Okay? I'll get one of those inflatable projector screens and we'll put it in the parking lot here at the office. Bring your tailgating chairs. Let's go. Okay. Just
That
had to
sounds
make
good.
sure y'all knew that. I can't believe that. That would be awesome. But D&D as well. Yeah, I'd love to launch a campaign. Let me know if y'all want to play. What if we played D&D live on Twitch? That would be so fun. And I'll be the dungeon master. Your brother can teach me how to DM. Okay, sorry, let's keep going.
Okay, so what we're gonna do?
Don't stare into the light, y'all. Don't look. Just kidding.
Let's not. Let's Jenna, if you could unplug the grasshopper.
Yeah, just showing y'all. I put monkey space under this one was like his little, his big eyes. And I was like, my little bear. And isn't that funny? I was like, I just want to see you close up. I did not have the light on. Okay, did you want me to plug back in?
Okay. Not yet. We're going to do some minor rewiring first. So go ahead and put the grasshopper plug down.
Yep.
It's still really tripping me up that like they still should not have lit, but like at least they're lighting.
Yeah.
Yeah. Let's see how this theory goes. If you could take out all 8 yellow LEDs.
Mm-hmm. Okay.
Okay, and now you have a plastic tub there with a tape roll full of resistors.
Yep, got it.
Like a whole pack of resistors. If you could grab those.
Like this?
That's correct. Those are all 220s. The only ones we have out today. So if you could pull one of those out.
Okay.
I'll show you what to do with one of them, and then we'll end up doing all 8.
Okay.
Grab one.
All right, where are we going?
Okay, so
Darren says, can we check the voltages from where the LEDs came from first?
We did. Was it like 1.7 or so?
Was it? Okay. 1.7.
Darren, did you want us to check them before we put anything new in, or what are you thinking?
Well, because when we checked it, they were plugged in. Maybe without them plugged in.
That actually works if they're not draining current, which was the theory here. So perhaps Jenna, if you could plug the grasshopper back in.
Okay, and then am I going to ground and then just to one of those spots?
Yeah, if you could check what's coming out of those like white cables. So.
Oh, nothing.
What?
Let me show you.
You're seeing. Okay, so basically 0. Something to do is to try to get the reds to light up. Jess, if you could step through, because you're the...
Yeah, so I think if you unplug it and plug it back in again, it should get them to light up. I think, did it turn off when we unplugged the LEDs?
I can't remember.
Yeah, we're not having the red ones. We want to make sure the red
ones light. I just plugged back in,
light.
and the reds are not lit up. Darren says, I'm wondering if the LEDs are behaving as pull-down resistors.
Yeah, that's really... Like, the reds were, like, semi-consistently lighting up in this state, like, when the LEDs were in. So, actually, I mean, he might have a point that, like, our currents were kind of being... So, I guess if we set load back to high, it's low right now,
That's this one, right?
Number 9.
Yeah.
Yeah. And then just ensure that enable is also high.
Yes.
Okay, so now unplug and replug the power.
Nada.
Okay, so this is, I mean, like, it should do nothing.
Okay,
if we set enable back to low and then cycle the clock, they should turn on. Like, in the perfect universe, this is how it should behave.
Okay, so am I turning the clock off?
Yeah. No, you're just hitting the clock once.
Oh.
Yeah, okay. So that's not working. But the way that we were getting them to light, like, that's like in the ideal situation, this is how it should work. The way we were getting it to light is by unplugging and then plugging back in the power in this state that we're in right now.
Should we try?
Yeah.
No. Should this be on low or no?
High.
Okay, it's on high. What about this one? This one's low. 15?
So, yeah.
Interesting, they're not lighting at all.
But they were lighting with the LEDs. I mean, that's just weird.
It's weird.
Well, let's try getting those resistors in there. Maybe set it up.
Okay.
So those 8 white cables that are coming down on the bottom right-hand side.
These?
Yeah, go ahead and put the resistor. You can go from the top half of that board to the bottom half of the board. You're kind of bridging the gap in the middle as you go downward.
So just like here?
Yes.
Like this?
Yeah, that's perfect. So that's good.
Okay.
And you're going to use the LED to go from where the bottom half of the resistor stuff plugs in to ground on the bottom half of the board there.
And so that's, I can't remember, we had the smaller leg in ground, right?
That's correct.
Did it matter actually okay, it starts here, right?
Oh no, back all the way on the bottom.
Oh, down here.
Yeah, so it goes kind of through the white cable, through the resistor, through the LED.
Gotcha, okay. So like this. And then do the next one?
Yeah, you'll want to do all 8 exactly.
All right. Alrighty.
Right now.
And what are you thinking is going to happen if you are explaining this to someone learning for the very first time? Why are we doing this?
We're doing because the LEDs often have resistors. They often have resistors in line with them in order to kind of slow down the amount of current that goes through that leg.
Mm-hmm.
Because all of that power is being provided by the power input to the 8-bit chip that you have, so the longer 8-bit chip. So by putting these resistors in place, make sure that there's not so much current going through them that it's actually like drowning out the chip, where the chip can't have enough power.
Sorry, my audio is pretty bad. I don't know. I don't know
Oh,
why.
there, that's better. I think you were just far away. Okay. How
This
we
may
doing?
be better, but okay.
Yeah, that's better.
Oh.
What'd you do?
Yeah. I pulled my headset cable closer to my face. It was kind of sitting on my shirt. So, some advanced debugging over here.
Doing the most and the least.
Yeah, but to summarize what I was saying there, the reason for doing this is to make sure that we're not kind of drawing so much power through that chip compared to how much can be input to it, that we are limiting it from functioning correctly. And Jess, I'm curious, or maybe even Darren as well, if you're listening in still, I'm curious if the red LEDs need them as well. Those are a lot more painful to wire, just given their position. So I'd rather not, if possible. Let's try just the yellows and see if we get anything different, because the reds somewhat have been behaving well.
Yeah, Jess and G-Days, y'all's kits worked, right?
Yeah.
I got maybe it's the only difference between y'all and me is that I'm not an engineer. So it's probably me and not the kit.
I was reading through some of the comments on Ben Eater's videos.
Oh.
And there's a lot of people that say they get very inconsistent behavior from the output of the
Oh, really?
So this is if I'll put the link in chat if everyone wants to read there. But if you read kind of the comments at the bottom, and then Darren has a question as well in chat regarding the output voltage from the chip. Maybe we can check that once we power it back on. We have checked intermittently, and sometimes they're good, sometimes they're not, but they have moved around quite a bit.
Yeah, like we were debugging that one the last time, like Jordan and I, and on the 4-bit registers, I believe we saw all the correct voltages, but then on the 8-bit, we were seeing really weird behavior. Like when enable should have made everything have a high voltage, it was like 0 on the B side, which is weird.
Now we're all going, Everyone at home is going, can hear y'all's Discord notifications. Are y'all chatting? Just so y'all know, sometimes they'll be chatting about funny things on Discord while we're streaming, and I'm like, hey, I want in. I want to know, what are y'all talking about?
It's basically us just going,
Actually, that's just
Wait, Jordan, we can't hear you. What happened?
We're discussing if we plan today to be 45 minutes or an hour. I can't remember.
Oh, Darren says, usually by this time I yank everything out and start over.
Okay, yeah, there are a lot of comments of people saying weird behavior.
Is it like the manufacturer of the parts, or is it?
One of them did actually say they tilted their board and something like turned off and on, which is the same thing that you did.
Do you think it's like a faulty breadboard?
The breadboard itself, no, but I am suspicious of at least one of the chips, but it is rather hard to tell so far.
Well, I did source every, so we got Ben Eater's kit, but I did source each part individually and got quotes from various manufacturers. We should look up who manufactures these things and who's the most reliable, and do our own kit.
The other thing we found funny, like last time when we were debugging, is that like we were looking through Ben Eater's schematic and like he doesn't actually have power and ground like powered on these things, and it's like we powered power and ground, but we were like, wait, does he know something we don't know?
Darren says sources of errors for me in the past: chip, breadboard, short from broken wire, static frying of components. So breadboard, it could be the breadboard. Hey Darren, on our first stream, you'll probably find this funny. I was not used to saying breadboard over and over, and I was clearly hungry, and so I was talking about it, and I called it a cheese board. It was so funny. I was like, oh, I'm clearly hungry. I don't think I've done that again, but Jordan, actually, we had a cheese board the other day, and Jordan, were you calling it a breadboard? Just gonna have a breadboard.
I did call it a breadboard.
Yeah. That's funny. Did I? Darren, have you heard, we had someone who was on here, charcuterie. We had someone who was on here one time when we were talking about how do you know which leg goes where, and they said the long leg is positive because positivity takes you further, which said that's why it's the longer leg, and I thought that was so sweet, and so I like saying that as much as I can. I thought that was a cute little, yep, we're gonna see that on a little hangy-do at Bed Bath & Beyond. The long leg of the LED goes into the positive pin because positivity takes you further. What if at Bed Bath & Beyond you saw things like that? People would be like, what are they talking about? Britt, same. That's why we can't say it. Darren, are there certain manufacturers that are more reliable than others? Or more recommended than others? And I actually need to find, Britt, did I send it to you, the comprehensive parts list when I like literally had every single piece sourced individually with the pricing and everything. So maybe if we can clean that up a little bit and share it with y'all. Yeah, it's a Google Doc. We'll clean that up and share it in case y'all have any ideas of certain manufacturers that are more reliable. Okay, I'm gonna have that in here. Oh, almost there. Almost. I wonder if anything was like, well, we don't really have, no, I'm thinking out loud. I'm not gonna say that thought out It's pretty random. Most commercial chips available publicly have a pretty high failure rate. Oh no. That's sad. Why? I wonder why. Okay, last one. That's disappointing, Darren. So, Darren, maybe while we're troubleshooting, if you could write a bit about the project that you're working on here. And I'll make sure to read it. I want to make sure I get it right. But yeah, you were a pro. You had the whole like streaming soon. I was like, oh, y'all, we got to get it together. You're a natural. Here we go. And so anyone just tuning in, we're building an 8-bit computer from scratch on breadboards. We're having some issues. I think we have a faulty breadboard. That's my assumption. I say we switch out the one of the breadboards because I want to get to the bottom of this. Let's do a true crime podcast on. Let's find out where the mistake was made in the manufacturing process of all of these parts. I'm just kidding. Ooh, Darren, their next project will be students building a circuit that emulates a COVID symptom detector. They are going to guide Darren as he builds it live on Twitch at 1:30 p.m. on July 2nd. That's so cool. Very, very cool. Okay, Jess Jordan, what do y'all, when y'all are quiet, I know y'all are over there like going, but what are you thinking when you go, Oh, goodness. Jess Jordan. Okay. Jordan, I can't hear you.
Probably with that. Hello? Hello?
Yo, we can hear you now. No, I don't.
My mic must be
I think
going
I think we have a troll in the chat. No, I don't want to be famous. And we would never buy followers. We only want quality followers. Okay. All right. Ooh, look how neatly these are lined up.
We're good.
Let me show y'all.
Nice.
Let me show y'all close up. Hang tight. Whoa. Okay, ladies, now let's get in formation. Look at that.
I've heard that line somewhere before.
Yes. Okay, ladies, now let's get in formation. Let's have Beyonce on the Twitch stream. Let's teach Beyonce.
Yeah, reading the comments, actually, a few people tried resistors through the LEDs and stuff. So
Oh,
this
okay.
is good.
In 99, is there a schematic? Britt, do you mind popping the instructions back in chat? And I believe we have most of the things in there.
Well, while we have a couple minutes left, because we have let me make sure you guys can hear me. We have a couple minutes left before we all have a hard cutoff at 2. So one more quick test. We'll have to connect a ground line, Jenna, between these LEDs and the ground for the rest of the board. So we'll have to do another one of those bridges from like the top half of the breadboard chunk to a bottom half to make sure that ground is connected.
Okay. And so this will be, I just need a jumper.
Yeah, I think there were a couple around that you made extra from last time.
Oh, like one of these.
Yeah,
and where am I
smaller
going?
ones. It'll go from ground to ground, so the bottom half of the close board to the top half of that board.
Let's see, this should reach.
Yeah, you had a couple extra, I think, right length.
How's that? Ground to ground.
That looks good.
Great.
So let's, well, Jess, if you want to go through the sequencing for plugging in the right order, because I never get it right. Power back
Let
up.
me go back to wide view. Okay. All right. Where am I going?
Okay, well, they should have lit.
Oh, already? They should have when we plug that in.
I mean, if we're reproducing the behavior we were seeing before, they should have lit, but actually let's try the like actual desired behavior. So if we set pin 9 back to high,
Okay.
and then just ensure also pin 19 is high.
Yes, it is.
Sweet. Okay, so cycle power. Sorry.
That's okay.
Okay, I mean nothing should happen, so don't worry.
I'm gonna make sure these are in well. Yeah, okay. We have one.
Okay, we have seen this before. Remember when we saw this, Jordan? That was weird.
That's
What
weird.
happens if you hit the clock? I'm just curious.
Going strong.
Okay, so the clock's lighting up. Okay, so if we set pin 9 back to low, and then we hit the clock again, they should light. All of them, not just the one. Okay,
super
so
strange.
like, what's the
Rats.
voltage on that one LED that's lit? Like, that's super weird.
So just part of this makes me think that can you guys hear me?
I can't hear you, Jordan.
You can?
Now I can. What's happening here?
Something I'm
nine.
thinking,
Wait,
Jeff.
that's it. I don't know if I'm going to the right spot.
Just as the weird behavior from those chips makes me think that we need the resistors on the red LEDs as well. That like very
Yeah.
inconsistent behavior and like ghost outputs that are inconsistent makes me think similarly of brownout. Jenna, can you check again? What was the voltage over those LEDs?
Of this one, just go to this row
Yeah,
and
like
then
this
ground.
Yeah, like any
Yeah.
of those LEDs actually.
Oh,
I
any
mean,
of
the
them?
one that's lit is really interesting, and then the ones that are
Well,
not,
the one
because
that's lit.
it
and then
lines
ground.
up actually with a lot of the comments, and that there might not be enough voltage for them to light.
It
Okay,
says
so that one's
2.1.
2. That's good. That makes sense why that one's lit.
Let me
because it
try
has
this
enough.
one.
It's
0.097.
not enough. Yeah, you're right. We need resistors. You're right.
So Jenna, what we're gonna do next time, and we or y'all, we have a hard cutoff right now. So we all have to hop on another call here. But yeah, we're gonna add some more resistors in for next time to make
Okay.
sure we get good behavior, because I think we're just drowning those chips. The LEDs are drawing too much current and
Right.
causing the chips to freak out. At least
Okay.
if our theory works there.
Well,
so
then
we'll call it there. But this was good.
Yeah, thanks, y'all. That was fun.
Yeah, this was. I feel way better about this now, honestly.
I know, and that was fun. Thank y'all so much, everyone, for helping Darren and everyone who was throwing out ideas. We love that. So thank you. So we are going to be, is our new time going to be, is it Wednesdays at 11? Or is that our regular time? We're traveling the rest of this week, and so we did this on Tuesday. But I think moving forward, it's going to be 11 a.m. Pacific every Wednesday. And we're gonna keep on keeping on with this project. And we do have the 7th and 8th grade students in Robeson County, North Carolina, tuning in as well and finishing their 8-bit computer with us. Well, not finishing, we're still really right in the thick of things, but we're having so much fun. So thank you so much, Jess, Jordan, Britt, Hannah, Luigi, Darren, everyone. And yes, Neuron Collider, debugging is tough. But yeah, we're excited. This is super fun. So we'll see y'all next week, and enjoy the rest of y'all's week. Thanks for coming.
Thanks, everyone.